Hello dear students, today we are going to study about the polygons. Polygon is a two-dimensional closed-shaped figure formed by straight lines. For example, triangle is a polygon formed by three straight lines. Quadrilateral is a polygon formed by the four straight lines. Pentagon is a polygon formed by the five straight lines, and so on. To study the polygons, we should know the basic concepts related to the polygons. First concept is sides. The polygon is formed due to the sides. For example, in given figure, you can see a hexagon. The sides are AB, BC, CD, ED, and so on. Then next concept is vertex. Vertex is the point of intersection of two edges or sides. For example, in a given figure, points A, C, F, B are the vertices. Next concept is diagonal. Diagonal is the line or line segment joining any two vertices which are not adjacent to each other. For example, in given figure, AB cannot be considered as diagonal, whereas AD can be considered as diagonal. Similarly, AF cannot be considered as diagonal, whereas FC can be considered as diagonal. Next concept is interior angle. The angle formed by two edges, the interior angle formed by two edges of a polygon is called interior angle. For example, in given figure, angle ABC is interior angle, DEF is also interior angle. In a hexagon, there are 6 interior angles, whereas in pentagon, there are 5 interior angles. That means if n is the sides of any polygon, then there will be n interior angles. Next concept is exterior angle. The linear pair of interior angle is called exterior angle. For example, angle ABH, which is the linear pair of angle ABC, is the exterior angle. So we can define the exterior angle as the angle formed by extension of any side with another side is called also exterior angle. The most important property of any polygon is sum of interior angles. Basically, in triangle, the sum of all angles is 180 degree. But if there is any other polygon having n sides, then how to find the angle sum property? For that, we select any vertex of that polygon and divide that polygon in number of triangles by drawing all possible diagonals. For example, you can see a hexagon in a given slide, and VF, BE and BD are the diagonals which are dividing this hexagon in 4 triangles. So sum of all interior angle in one triangle is 180 degree. Therefore, sum of all interior angles, sum of all interior angle in that hexagon is 180 multiplied by 4 triangles. So we can derive the general formula. The sum of all interior angles is equal to 180 multiplied by number of triangles. If n is the number of sides, the number of triangles by such division by the diagonals will be n by 2. That means if n is the number of sides, then by selecting any vertex and drawing all possible diagonals, that polygon can be divided into n minus 2 triangles. So we can directly apply n is equal to 6 for the hexagon. So 180 multiplied by 6 minus 2, that will be 720 degrees. So angle sum property or sum of all interior angles in hexagon is 720 degree. This is one of the most important property in a polygon. Next property is sum of all exterior angles. This is very interesting property. For any polygon, sum of all exterior angles taken in a cyclic order is always 360 degree. For example, you can see a pentagon. The angle A, the exterior angle A, plus exterior angle B, plus C, plus D, and plus exterior angle E, their all sum is 360 degree. And in given hexagon, sum of all exterior angle is 360 degree. The order doesn't matter. You can take the order either in clockwise order or in anti-clockwise order. In pentagon, you can see we have added all exterior angle taken in clockwise order, and in hexagon you can see the sum of all external angle taken in anti-clockwise order is 360 degree. This is the most interesting part of any polygon, how to count the number of diagonals in a given polygon of n sides. There are two different methods. The first method is select any vertex and try to draw all possible diagonals. For example, you can see a pentagon. From first vertex you can see two diagonals. Second vertex, again there are two diagonals, and count all possible diagonals from all the vertices. In this process, every diagonal is counted 2 times. Therefore, number of diagonals will be maximum diagonals from a vertex multiplied by number of all vertices, and this product has to be divided by 2. Divided by 2, we are doing this because every diagonal is counted 2 times. If there are n sides or n vertices, then the maximum diagonals from a vertex is always n minus 3. Therefore, number of diagonals will be n minus 3 multiplied by number of vertices, that is n, divided by 2. For example, in a pentagon, n will be 5. Therefore, number of diagonals will be in bracket 5 minus 3, that is number of maximum diagonals from a vertex, multiplied by 5, that is number of vertices, divided by 2. The solution of this is 5. Therefore, there are 5 interior diagonals in a pentagon. Number of diagonals can be determined by the method of permutation and combination. Here, to count the diagonals, we will count the combination of 2 vertices selected out of n vertices, and from that we will subtract the number of sides. If there are n vertices, a diagonal can be formed by selecting any 2 vertices. In fact, sides can also be formed by selecting any 2 vertices. So, number of diagonals will be number of all possible combination of 2 vertices selected out of n vertices minus number of sides. So, if n is the number of sides or n is the number of vertices, then 2 vertices selected out of n vertices will be nc2 minus n, where n is the number of sides. For example, in given hexagon, there are 6 vertices. The 2 vertices out of 6 vertices can be selected by nc2 ways, that is 6 into 5 divided by 2 into 1, and answer is 15. From this 15, we will subtract the number of sides, that is 6. So, 9 is the diagonals in the hexagon. Note that nc2 is nothing but n minus 1 divided by 2. So, in this way we can determine the answer for nc2.